Hello everybody, just going through a question that I was shown by one of my students, which I didn't get initially, so I need to practice a little bit more. But here's pretty much what's going on. The question starts off by saying that AD, which by the way this is the D, it has a length of 4. AB at the top has a length of 8, and that means that the length down the bottom will also be 8, and the length on the side there will also be 4. It's saying if PD equals PB, so that's PD, P to the D, so pretty much the length of this left-hand triangle. If that is the same as PB, the hypotenuse of that right-hand side triangle, then you need to find the length of PB with that information. Now, the way that we'll go about finding this information is by using Pythagoras and also just remembering that we've got to have no more unknowns than what we have independent equations. So our way of being able to do that is by substituting a measurement down the bottom instead of doing it in terms of another unknown. So for example, calling something like between P and C, calling that X, or giving it another unknown that we're not aware of. We're instead going to be using it in terms of an unknown that we already know. So I'm going to call the length from PB, I'm just going to give it a letter because that makes it a little bit easier for me, I find. I'm just going to call that A. And as we know, PB has length A, and we know that that's the same as what PD is, because it says it here, PD equals PB. Okay, so you can call these anything you want, but they need to be the same thing. Now, I'm just going to show this maybe a little bit clearer on the side so we don't have as many things in the way. If at that corner is D, and up to the middle point there, or roughly middle point there, where we have the intersecting lines, we call this length A, and the whole thing is 8. Then to go from C to P will be a length of 8 minus A. So we can call that length 8 minus A, because that's exactly what it would be. If we add A with this 8 minus A, we end up getting an entire length of 8 down the bottom. Okay, so that there is 8 minus A. I'm just writing that really small, but yeah, hopefully that's clear enough as to what is going on, how I've ended up substituting something in terms of A into this triangle. Now, when I end up doing my Pythagoras equation for this right-hand side triangle, which hopefully we know, it's the general a squared plus b squared equals c squared, your square of your two sides will equal your hypotenuse. I'll just write that one down in general for people who might not have remembered. Your A, your B, and your C, with the C being the hypotenuse, and just a very rough example there. So we're going to be using that formula to try to solve this question. So we're working on this right hand side triangle that we've got here. So my base is going to be 8 minus A, and that's going to be squared, and I'm going to add the side there, which we know is 4 from B to C. That's the height of the triangle. That's 4 squared. So there's my AB squared, and then we need the hypotenuse, which we don't know what it is, except we know that I've given it the letter A squared. We've got one unknown, A, and we've got one line, one independent equation. Because the number of unknowns is equal to the number of equations I've got, that means that I'm going to be able to solve this. It would be the same thing if you had 6 plus A equals 10. You'll be able to solve that because you've only got one unknown in one equation. If you had something like 6 plus A plus B equals 10, you can't do it. You've got too many unknowns. You've got more unknowns than you've got independent equations. So that can't be solved. Okay, moving on. We now just need to expand all this. Now, 8 minus A all squared means this. Okay, and 4 squared, easy. 4 times 4 is 16. And a squared, we still don't know what a is, so we just leave it just as it is. Now, if you use the FOIL method for things in brackets, hopefully we've seen this before. It means first, then O for outer, then inner, and then last. Okay, and it's multiplication between all these numbers, and you've got to pay close attention to the signs. Okay, so for example, a minus multiplied by another minus will end up being a positive. Okay, so you've got to be very careful of that. Okay, 8, so we'll do first. 8 times 8 is 64. Then we do outer. 8 multiplied by minus a will be minus 8a. Inner, minus a multiplied by 8 will also be minus 8a. And then your minus a multiplied by minus a is the exact example I was talking about. Minus times a minus makes a positive. Minus a times minus a equals a squared. And then we keep the other things that we already had. They remain the same. Now we're going to combine what is known as like terms. So we're putting things together which are similar. 64 and 16, they're both just constants. They're both just normal numbers. We can add them together. We add because of the plus that's over here, not because of the minus there. The minus is attached to the 8a, not to something else later on. 64 plus 16 is 80. Minus 8a minus 8a will end up being minus 16a. And then we've got our a squared still there, and we equal a squared on the other side. Now, just like with something as simple as this one over here, the key to being able to solve this is to get a by itself. So for this one, we end up subtracting that from both sides to end up getting this. Easy enough. We've got to do the same sort of thing here. So we've got an a squared there, and we've got an a squared there. I want them to be on the same side. And one way that does this, and it's actually quite convenient to get the a's over to that side, or at least to get rid of this a squared, is I see that they're common to both sides, so I can just minus a squared from both sides. If I minus a squared from here, it will be a 0. So the left-hand side ends up looking like this. And if I minus a squared from this side, it will be a 0. So it ends up looking like this. Now, when it comes to getting the a over to the other side, and generally speaking, you want to get your unknown to be positive number. It just makes it look a little bit cleaner, a little bit easier, a little bit less complicated. So I'm going to plus the minus 16a over to that side, as opposed to minusing the 80. Okay, so if I plus 16a to both sides, that 16a will disappear. And over here, we're adding 16a. We get 80 equals 16a. Now, we just need to get a by itself. And the way to get a by itself is to divide this side by 16. That's what will get a by itself. So I'll just write divide both sides by 16. 16a divided by 16 will give us 1a, which we know is a. And a divided by 16 is 5. So the answer for this value here is 5. And to show how this will end up making sense as well, I will end up doing this. I'll end up making that original triangle on the side, just drawing it freehand, so sorry if it's a bit rubbish. Just move my camera a little bit. Okay, so we did initially say that this bottom is 8 minus a. We're saying that the a is now 5, and we're saying that the height we already knew was 4. The way that we'd normally solve this, let's just call this x for the time being, the base there. If I do 4 squared plus x squared equals 5 squared, This should be a pretty familiar triangle to a lot of people. That gets 25, this gets 16. The gap between them is 9, and therefore we minus 16 from both sides. We get x squared equals 25 take 16 is 9, and therefore the square root of x squared will be x if we square root both sides, and the square root of 9 will equal to 3. And obviously that makes sense, and it also makes sense. We're calling this 8 minus a. 8 minus 5 equals 3. It all adds up perfectly. So yeah, that's how to solve this question. It's a bit of a lengthier description that I've given because I wanted to make sure that all aspects of it were rather clear for when you have similar questions like this. Yeah, leave any questions in the comments below and have a wonderful day. Thank you so much for your time.